Yeah, good morning, all. So, today we are going to discuss about the congestion control and flow control. So, in this, we are going to discuss about how the congestion control and flow control are affecting, especially in wireless sensor network. So, in this, we are going to cover how the congestion is a serious problem for sensor networks and what are the network specific issues that are we need to consider while dealing with congestion in especially in again sensor networks, and then we look into some of the solutions which are proposed by various researchers to handle the congestion as well as flow control in sensor networks. Again somebody joined. So main sources we are going to discuss about how we are going to detect the congestion as well as reliability issues, congestion detection schemes, and multi-hop packet forwarding, how we are going to recover the errors. So now our lecture is going to be discussed at this stage. So data dissemination, storage, caching, as well as congestion control. So in this layer, we are our congestion control is going to be happen. Basically, when the usually the network congestion is a big headache in any sort of network, not only in wireless sensor network, in any sort of network, this particular congestion control is becoming the big headache. So when this congestion is happening in any particular network, it is going to be have the wastage of resources or the communication resources. Simply, we can say that like energy or other sort of resources, so on. So when the reliability of the data, when the data is going to be delivered, and at that particular situation, let us assume that so the contention is affecting seriously, and this is due to that the congestion. When we have congestion, definitely that packets are going to be dropped. So when the packets are going to be dropped, that means when we have going to decrease the overall performance of that particular network. So in case of wired network, we have fixed bandwidth, but in the case of wireless network, we cannot assure or we cannot have the fixed bandwidth in all the cases. So as it is wireless medium, we are going to have the bandwidth is fluctuated very regularly based on the distance or based on, let us assume that we are deploying deploying the sensors in random manner. So once the sensors are deployed, either they have to communicate with each other or they may have some cluster kind of scenario. So when these clusters are formed, several researchers suggested that various approaches to form the cluster. Some are considered that based on the distance the clusters are formed. Some are considered based on the signal strength they are forming the clusters, or based on the battery or energy level, residual energy level, they are going to consider the forming the clusters. So that's why in wireless sensor network, there is no fixed bandwidth allocated for any particular node. So first of all, when the sensor node is broadcasting the information or the sensor node is sending the information to other nodes, so usually the kind of transmission is with the radio frequency. So, as the data is transmitted through the radio frequency, we cannot predict at what time the frequency is good and at what time the channel quality is bad. So, this particular channel quality and radio interference can change and reduce the amount of bandwidth available for that particular data what we are going to transfer. So that's why when we have network congestion, definitely that leads to wastage of communication resources, or it leads to wastage of the resources which are related to energy, and the reliability issues also we are going to face at when network congestion is framed. So because of this radio frequency, we cannot predict uh, the available bandwidth for the data transmission. And at the same time, whenever we are going to add some extra number of nodes for that particular network into the sensor network, so there may be a possibility of getting more interference, at the same time congestion. So finally, what is going to happen is in this particular sensor networks. So this the traffic patterns can be derived from the what we can call the physical processes. So when the events are occurred in the wireless sensor network at the sync node or base station, then definitely the result is going to be congestion. So especially when we are dealing with sensor network, there are some unique sources like unique sources of congestion. So in this case, this congestion due to wireless sensor network, when we have multi-hop communication, or when the nodes are sharing the common communication medium like air. In the case of wireless sensor network, the air is the common communication medium to transmit the information or transmit the control packet or data packet from one location to another location, or one node to another node. At the same time, we have the issues like what we discussed in the previous classes, like multi-hop communication or multi-hop nodes. And in these cases also, we are going to face the problem of congestion. So in these networks, we have we everybody knows that we have a limited buffer size, a limited processing power. So because of this limited buffer size, just a kilobytes of information, not even megabytes, a kilobytes of information is going to be stored in that particular buffer. So if the buffer is going to be filled, then there is we cannot store that information in that particular buffer. Again, in that case also, we are going to have the congestion. So there is a limited buffer, as we are saying that, then only a small amount of data can be stored in that particular buffer. So if we have too much of information that has to be transmitted, it is not possible to store in that particular buffer. So in that case, buffer is not there, and there is no possibility of storing the information in that particular sensor network due to the limited size and limited capacity. So definitely in that case, we are going to face the problem of packet drop. There is no other option other than the packet drop. So if you have buffer empty space, if you have empty space in that particular buffer, then we are going to store to overcome the problem of congestion. That particular data is going to be stored in the buffer. When the buffer is going to be filled, then definitely the packet drop is going to be happen in that particular sensor network. So when we have unnamed or unmanaged, then at that time also they are going to be we are going to face the problem of congestion. So the main sources of congestion are when we have the channel contention, or when we have interference, or when we have more number of events to be occurred in the sensor node in different locations simultaneously, or when we have the collisions in the packet transmission or reporting rate, or the nature of that particular node transmission. In these cases, there is a possibility of getting congestion. So once that particular source node was detected an event, when an event is occurred, definitely, as we know that in previous classes we discussed that the source node has to detect that particular event. So when that particular source node is detecting that particular event, then they will send their list of that the event has to be notified to all the neighboring nodes by that particular source node. So at that particular time, they all are trying to broadcast or simply pump the data towards towards their connecting neighbors. by stating that this at this particular point of time the event was occurred. So if you look at the from next neighbor perspective, let us assume that. So all the sensitive data at the same time, once the event had occurred, that has to be transmitted to the different nodes. Again, we are facing the problem of transmission. The same data is transmitted by the multiple nodes. So in this case also, we are going to get the problem of congestion. So we have a different flows or we have different data transmissions that are coming from the different source nodes towards the sync node. So the congestion is likely to occur at any node, either intermediate node or the source node or the destination node. There is a possibility of getting uh, the congestion because of the different flows transmitted from the different nodes at the same time. So the congestion may occur. There is a more possibility of getting the congestion at the intermediate nodes. So which lies in between source and destination node. In that case also. So what is required to analyze that particular different issues with the congestion as well as contention that are required for deploying the wireless sensor networks when we have deployed the sensor networks randomly. So there are some goals of congestion control. The main goal of the congestion control is to uh, definitely increase the network efficiency. Whatever the researchers done on the congestion control, definitely the researcher is trying to increase the network efficiency by minimizing the power consumption or minimizing the contention based transmission or the minimizing some other kind of scenarios, but the overall result of that particular research is to improve the efficiency of that particular network lifetime, or simply we can have the quality of the network will be improved. So when we have the efficient network resources, that means when we are able to use the network resources very efficiently, then definitely the utilization of the definitely the network lifetime is going to be improved. That means if we have one resource, we should make that particular resources very busy so that that particular resource is the utilization of that particular resource is to be maximized. So when we are using the maximum utilization of that particular resources, definitely the network is going to be improved. So in this case, we have some set of tasks to perform by the source node or the sync node or the destination node, and we have some set of resources to perform that particular task. So in that case, so there is a possibility of getting scheduled which resource is allocated for which task. So the efficient manner of allocating the resources, again, that is called fairness. So more fairness, more efficiency; less fairness, less efficiency in the case of sensor networks. So there are some scenarios for congestion control. So usually when we have sensor nodes deployed in dense environment, or when we have deployed a sensor nodes which is having low rate, sparsely deployed sensors, or we can say that sparsely deployed sensors at high rate. There are three scenarios where the congestion can be controlled, or we may face the congestion that has to be controlled. So in the case of densely deployed sensors, what we can observe is when these particular sensors are deployed in dense environment, definitely which will leads to the, we can call it as persistent hotspots. So these hotspot is just like a node or simply a group of nodes in the particular location where this congestion is to be occurred and leads to be packet drops. So here we are saying that persistent and transient, two words we are using here. The persistent means the hotspot is going to be remain for longer period of time. So the hotspot is not going to change. It will not change the location. At the same time, the hotspot remains itself. It will not perform any other operation. So these nodes which are hotspots will remain as hotspots for a longer period of time. So in this case, there is a possibility of getting congestion near to that particular hotspots where the source node near to that particular source node there is a possibility of getting congestion. So in the case of sparsely deployed sensors, we are saying low rate as well as high rate. The sparsely deployed sensors with low data feeding, so this will leads to again transient hotspots, and this congestion is likely to occur anywhere, but which may not be near to the source node. The hotspots may occur far from the source node. The nodes which are near to the source node, in that case, there is no possibility of getting hotspot by that particular node, but the hotspots were occurred which are far away from that particular source. What I mean to say here is the spots for the hotspots for congestion are likely to be usually far away from the sources, but closer to the sync node. They are closer to the sync node but far away from that source node. In the case of sparsely deployed with high rate, will leads to both the persistent as well as the transient hotspots, just like a hybrid. So, and these hotspots are formed are going to be distributed throughout the network, but not just localized in a particular part of the region. So in the case of high rate, as the name suggesting that the rate is high, the transmission rate is high, the flow rate is high. So in faster manner the transmission will be occurred. So there is a possibility of getting multiple hotspots simultaneously in different locations. So that is called sparsely deployed sensors with high rate, sparsely deployed sensors with low rate, and densely deployed sensors. So in densely deployed sensors, the persistent hotspots are formed. In this, once the hotspot is formed, it will not change. It will stay for longer period of time. But in the case, the hotspots may occur which is very near to the source node. But in the case of sparsely deployed sensors with low rate, the transient hotspots are occurred which are not near to the source node but near to the sync node. In the case of sparsely deployed sensors with high rate, both hotspots may occur simultaneously in different locations. So, some issues we are going to discuss now for congestion. So, usually this is general phenomena in any network, not only in wireless sensor network. When any congestion occurred, we need to detect that. That has to be notified to the neighbors, and we need to control that. So there are the three issues where we have basic issues we have in congestion. So there are some other issues like this with congestion control, but we are talking about only in view of wireless sensor network. So in this case, the first basic thing is detecting that particular congestion. So once the congestion was detected, this particular congestion has to be notified, and then we need to control that particular congestion. So in the case of congestion detection, there are some couple of ways in which the congestion can be detected. So the usual thing is, as we said now, every node is having one buffer, right? So the basic thing in congestion detection is we need to monitor the buffer. So if we expect when the buffer is going to be filled, then almost we are successful in controlling the congestion. Because when the buffer is full, there is no possibility of storing that particular information which is going to be transmitted by the sensor. So when the buffer is full, definitely the congestion is going to be happen. So If we monitor the buffer continuously, then we are going to have some control on that particular congestion. This particular buffer monitoring as well as managing at different nodes, different sensor nodes. So, how this particular buffer is going to be filled. And the other thing in congestion detection is monitoring that particular channel whether it is busy or not. Or by estimating, we need to estimate the load of that particular channel when it is going to be busy. The third is to monitoring the inter-packet arrival time with respect to both data packets as well as control packets. So these are the three things we need to have in detecting that particular congestion. Because sometimes, if any sensor node is broadcasting the control packet, we know that there are two kinds of packets are transmitted in the sensor network: control packet as well as data packet. So before sending the data, it has to send the control packet so that both are communicating with each other whether they are going to receive whether they are ready to receive the data or not. So once the control packets are transmitted, it has to send the data packet. Before that, we need to establish the path. Here, to establish a communication path between source and destination or the node and sync node, these there are so many control packets are transmitted in case of establishing the path. Let us assume that we are forming a clusters for sensors. Now, once the clusters are formed, it has to select the cluster head. Again, there are so many ways to select the cluster head. And again, n number of control packets has to be exchanged between nodes and the cluster head to select that to choose that one node as the cluster head. If we minimize that particular control packets, definitely we are going to have the control on that particular congestion, because there are so many control packets has to be exchanged before establishing the path. Now the some of the researchers are also working on this, how to reduce the control packets between node and the sync node, or between node and cluster head, or cluster head to sync node. So this particular research is going on at present. So once the congestion was detected, then congestion notification has to be taken place. So in this, it has to be notified to that particular source node who initiate that particular transmission, so that the source node came to know there was some high load in that particular channel. So it has to reroute that particular packet, or it will choose another scenario to send that information to the sync node or the other node. So the node which is detected the congestion has to notify in the form of just like a packet header, or by stating that the congestion is occurred. So either we need to notify the source node, or it can be broadcasted to some other nodes in that particular neighbors, and it may be all the nodes in the network will came to know that this in this particular location the congestion was happened. So how many nodes are there? If we have clustered, in that cluster every node has to notify that in this particular node or at this particular location the congestion is happened, like that it has to notify. So once the congestion is notified, then the source node or the sync node is trying to control that particular congestion. So where this basically involves in dynamic reporting. You can call that as dynamic reporting. And if the congestion is coming closer or it is going to be happen, then it has to control the congestion at the rate at which the source node should send the data to report. That means it has to controlled by the nodes which are affected by the congestion. So in the network, the data reduction techniques on the congestion are required in order to control that particular congestion. So instead of flooding the data, we need to reduce that particular data flooding. We have some algorithms that we are going to discuss now. So with that algorithms, we are going to reduce the flow of data so that the congestion will be controlled. So we have several protocols for congestion control, and we are going to discuss some of the major protocols for congestion control. So the first is event to sync reliable transport protocol. In this, what we are going to have is it will control the flow of data. That means if the frequency is low, the flow frequency is low, what this protocol suggests is it will increase the frequency. If the frequency is high than the load of that particular channel, then it is going to reduce the frequency of the packet transmission. So the name itself it's suggesting that even to sync reliable transport protocol. So it says that if more packets are received than needed, then it will reduce the flow of the packet. If receiving packets are too few, that is less than the required, then it will increase the frequency of that particular packets in that sensor networks. So if there are that means the based on as we can see from the screen here, no need for E to E retransmissions. That means because of these fluctuations, controlling the fluctuations, there is no end to end retransmissions are required. That means no packet is going to be retransmitted because it controls the flow of packet from source to destination. That means each node is going to maintain one table just like PCB. So in that table, it will have how many packets are transmitted by that particular intermediary node and how many packets are flooded from which node. Like that, it will maintain some kind of information in that particular table. So based on that, we can estimate the source or the sync node can estimate the load what that particular node is having. So based on that, this protocol will control, will reroute that, redirected that particular packet to some other through other intermediary nodes. So when it is this particular event to sync reliable protocol, as I given the link of this particular paper in this slide, so you can open that and you can see that. So the author suggested that he did this evaluation based on some assumptions. So he assumed that that particular flow control is prescribed only at the sink. That means the sink node itself, it is prescribing on which node what type of flow control it has to allow. And the complexity not allowed at network layer or MAC layer. So there is no complexity when the packets are converted or when the packets are transmitted or when the header is added or footer is added. The network layer or the MAC layer should not face any complexity in making that particular, preparing that particular packet. And syncs can be within the network. That means when we have heterogeneous networks, then there is a need of more intertransmissions are required. So he assumes that that sync node is also available within the same network. So reliability, he assumes that there is no wireless channel contention. He assumes that there is a fixed bandwidth allocated for this particular wireless sensor network. So by assuming this, he evaluated this event to sync reliable transport protocol. So when the syncs can be within the network. How it is possible? How we can assure that the sync is always available within the same network? That means sometimes the syncs can be existing within the network itself, and sometimes if suppose the sync is outside that particular network, this according to his assumption, this particular protocol is not going to perform in efficient manner. So the like this, there are some drawbacks in the specifications given by the author. So, but how the problem of contention has to be defined by this particular protocol, we are going to discuss about this. So here, congestion detection as well as the reliability. As per his assessment, these two are done at the sync node. These two are done at the sync node. That is both congestion detection as well as the reliability level are to be done at the sync node. So in this particular protocol, this according to ESRT, the congestion detection is taken care as that particular nodes monitor their buffer sizes, and they inform that the sync node by setting the flag bit of that header of that particular packets. And if suppose if any overflow occurs, it has to update the header field of that particular packet. And for at the same time, further to check the level of reliability or the reliability level, it is calculated by the sync node at the end of each interval. We know very well the networks are going to be refreshed at some regular point of time. Based on the size of network, the time may vary, but when the networks are refreshed, it is going to be collect the information of it is going to be calculate by the sync node the reliability level. How many packets are transmitted successfully? How many packets are dropped because of congestion or some other physical related issues? So the sync node has to calculate the reliability level at each and every refreshment, regular intervals. So if for that the reliability level, what the according to this paper, what is suggested is he used to have one flag bit. So if the reliability level is high in the packet itself, he is going to add one more field called bit one. He is going to add one bit header called one. If the reliability level is low, then that bit is going to be changed to 0. So in this case, when the bit is 1, simply we can say that there is a the congestion, the possibility of getting congestion is very high, and when we have bit 0, the possibility of getting congestion is very low. So according to this ESRT, he said that this particular protocol can be implemented in real-time applications. Real-time applications. So when we are going to implement in real-time application, he assumes that the incoming traffic does not change per interval. That means he allowed a fixed size packets, fixed size traffic flow into that particular network. At the same time, he controlled the congestion based on if that particular current buffer plus last change at the time of last refreshment, what changes are occurred for that header, that the summation of these two, if it is more than the maximum buffer, then we will going to change the congestion bit 1 to 0 or 0 to 1 based on this. The current buffer size plus last change, what the change happened in that particular buffer, the sum of these two is more than the maximum buffer, then the congestion has to be notified that particular bit. So so another protocol we have is called CODA, congestion detection and avoidance. So in this, according again, this also I took from another paper, so that will also attach it to you. So this particular protocol is energy efficient as well as congestion control protocol. So this particular congestion detection and avoidance, it will detect as well as it will avoid. Okay. So in previous case, it is not avoiding, simply it is controlling the congestion, but it is simply it will detect as well as it will avoid the congestion. So this, especially this particular protocol, will consider the issue of energy consumption. So based on the energy consumption of that particular node, he suggested that three mechanisms that are to be involved in implementing this particular code. One is congestion detection, and the second one is called open loop back pressure, and the third one is called closed loop multi-source regulation. These are the three mechanisms suggested. We can see that in open loop, when we use buffer occupancy and when we have channel sampling to detect that particular congestion, assumes that event occurrence as a source of congestion, not wireless links or that particular interference. So the major goal of this particular protocol is to minimize the congestion in both the cases of transient as well as persistent, as we discussed in the just before. So once that particular congestion was detected, this particular congestion detection and avoidance protocol prescribes that a open loop hope by hope back pressure. That means there is no loop. We can say that open loop hope by hope back pressure. That is one node by one node. It will send back. It will pump that particular packet back to the node from where it receives that particular request or the particular data packet. So in this case, the whatever the intermediate nodes we have, in communication process, that nodes has to inform the neighbors about that particular congestion, and here no feedback is received once that particular packet was delivered to the source or no delivered from the source to destination. In return, there is no feedback has to be returned according to this. So, if there is no feedback from the receiver towards that particular source, he suggested that another mechanism called closed loop multi source regulation. So, in this, the feedback from the receiver or the destination is sent to the source after the congestion is detected. That means in open loop, there is no feedback was transmitted from destination to source. In the case of closed loop, it will send the feedback, but after congestion was detected. If there is no congestion, it is also not sending any feedback to the source. So once the congestion was detected at the time, the feedback is going to be transmitted from receiver to the sync node or the source node. So the basic difference between open loop and closed loop mechanisms are, in open loop mechanism, the intermediate nodes are informed about the congestion, but in the case of closed loop, the receiver is going to inform the source node about the congestion. That's why after the congestion was detected at the time only it is going to send the feedback. So it is only exclusively it is going to send the feedback for the source node. So once the congestion was detected, according to this CODA protocol, it has accurate as well as efficient congestion detection is very important for efficient transmission of data. To perform the data efficiently or perfectly or smoothly, then we need to have accurate detection of this congestion. But according to this, there are some misconceptions in this paper itself. We can found in that. So in this case, the combination of back pressure with closed loop congestion control. That means it basically, this particular protocol, what it does is after congestion was detected, it combines the back pressure, that means open loop as well as the closed loop, to control that particular congestion. So this particular back pressure mechanism, the open loop one, basically targets the local conditions, whereas this closed loop will regulate that particular target. Whatever the target we have, that has to be regulated. So this closed loop regulation targets the persistent condition, whatever we discussed in the previous slide. So, and how this particular source node has to be notified explicitly is not specified in the paper. He said only the source node is going to be exclusively notify that the congestion detection, but in which process it is going to be notified, that is not specified in this particular paper. And this source node towards the node which is experiencing that congestion, the congestion control mechanism is going to be invoked, this said simply. But when the, as the previous back pressure mechanism, when the intermediate node detects that particular congestion, then in that case, whether it is forward direction or backward direction is not specified, simply said notified. To whom it is notified, the source node or the sink node or the destination node or the neighboring nodes, it is not specified. And he given some performance matrices to detect the congestion as well as the avoidance. So he took the average energy tax, at the same time average fidelity penalty. So how many packets are dropped in that particular network and how many packets are received by that particular sync node. So if the ratio between these two, it will be considered as average energy tax, and that fidelity penalty is calculated by the difference between the average number of packets delivered at the sink and at the time of normal condition, where the performance matrices is suggested. So as we said, open loop as well as closed loop. So we can see here in open loop back pressure, let us assume that we can see on the top of the slide, red color nodes are there 1, 2, 3, 4, 5, 6. Let us assume that at node 5 the congestion has occurred. So open loop hope by hope back pressure, that means where the congestion is occurred at that node, it will reverse the packet. It will not forward the packet. It will reverse the packet to from where it receives that. So definitely from this figure, the node 4 is transmitting the packet to node 5 here. At node 5, the congestion is detected. Let us assume that. Then what it has to do? Hope by hope back pressure. It will not directly send to the source, but it will simply one step back to the node from where it receives that particular packet. So definitely node 5 has to back pressure that particular packet to node 4. Then node 4, what he has to do? From node 4, it has to pump back either to node 1 or node 2, not the both. Any one node to any one node, it has to transmit. So likewise, hope by hope back pressure. So in, as we said now, each node is going to be maintain one buffer. So that buffer is going to, when the buffer is going to be filled, then the congestion is going to be happen. In this case, what we can see is the queue occupancy based congestion detection. He proposed that queue occupancy based congestion detection. That means each node, we can see here from left side figure, there are 4 nodes, and for each and every node there is a buffer. And the last bit is red color, as we said, to represent 0 or 1. So each node is going to have one, it is maintaining one buffer or simply queue. We can call this particular buffer or queue as outgoing buffer or outgoing queue. That means it will record the packets which are transmitted from that particular node. So outgoing packets, it is going to be maintained. So when that particular queue occupancy exceeds some threshold value, it says that local congestion is happening. So that in that at that particular node, so many packets are flooded into that particular queue. When that particular queue is going to be filled, or it is going to exceed some threshold value, here we specified some alpha. I will tell you why alpha is used here. When that particular occupancy exceeds the threshold value, then it indicates the local congestion. So in this case, once there is no congestion, let us assume that all the queues are having empty space or buffer space. So in that case, what is going to happen? It is transmitting the packet to uh, its neighboring node towards that particular sync node. So every packet header is going to have one congestion bit. Here, right side figure you can see here, the bit is having one. Okay. So if locally congested, that it will set the congestion bit, then it will revert the back. If there is no congestion, then it will simply transfer the packet to the corresponding sync node. So in the case of multi-hop, closed loop multi-source regulation, closed loop, in this what we are going to have is, in this particular approach, where the explicitly source node is going to be notified, as we can see that. So in this particular case, let us consider we have a scenario like this, according to this figure. So we have node 1 and node 2. Let us say that three packets 1, 2, 3 are sent, and then the corresponding acknowledgements is sent back from node 2 to node 1. Then the corresponding, after receiving that corresponding acknowledgements, 4, 5, 6, it will send to the source node, node 2. So after 4, 5, 6, as we can see here, there is no acknowledgement sent, because that, let us assume that the congestion was detected. Here we are representing with red color line here. At this particular point of time, the congestion was detected. So after receiving the package 456, there is no acknowledgement is transmitting back to node 1. But because that particular congestion was detected after receiving the packet 456. So in this case, we need to regulate. So the closure loop has to regulate that particular congestion. So what it has to do in this particular case, the acknowledgement is not received. So what the node 2 will do is, it will not send any control packet or data packet, towards the node 1. Then let us say that the packet 7 and 8 also transmitted from node 1 to node 2. Let us assume that. And node 2 received 7, 8 also. Now 4, 5, 6, 7, 8 packet, up to 5 packets are there at the destination node called 2. So then after, it will send the acknowledgement back to the node 1. That means when the congestion was occurred, it will not send any acknowledgement uh, to node 1, because it has to take care of that particular congestion. So once that particular acknowledgement is going to be sent back to the node to state that, to update that particular bit field of in that particular packet header, 0 to 1 or 1 to 0. So when we compare this CODA and ESRT protocols, so this ESRT protocol explicitly taken the energy issue into consideration to detect as well as control the congestion. But in the case of this CODA, it will able to handle that both persistent as well as the transient congestions without any allegations. So now we have some schemes. I'm not going to get in detail about this. One is called buffer occupancy, second one is called channel loading, and the third one is called reporting. So buffer occupancy means how much buffer is going to be occupied at that particular node. So based on the buffer occupancy, the load balancing will be happen, channel loading will be happen, and report rate. When report rate goes down, that means the congestion is going to be happened. So another protocol we have is pump slow, fetch quickly. The name suggesting that pump slow, that means it will transmit very slow, fetch quickly, receive the packet in faster manner. So the whatever the observations are like the most sensor network applications, they do not require 100% reliability. We cannot assure that 100% reliability. So so there are some applications like tasking of sensor. They need definitely they need to have reliable delivery. So both in both of these cases, that is 100% of packet delivery, and in these cases, as we can see that in the first case, the data transmission takes place from source node toward the sync node, and the second case, the sync node towards the source node. So the current sensor networks are most of the current sensor networks are the application specific and are optimized for that particular purpose. So future sensor networks may be general purpose to some extent, and they have ability to reprogram functionality. That means automatically they has to maintain they have the facilities of SDN, software defined network. So the main goal of this pump slow fetch quickly is to provide lossless delivery, minimize control overhead, because that particular there are more number of control packets we are sending, the more control overhead. The more control overhead means more energy consumption, and we have highly energy consistent constant network, that these particular sensor networks are highly energy constant, and we want to minimize this kind of control overheads. As we said previously, we need to reduce the number of control packets which are transmitted from one node to another node or node to sync node. So the third goal of this particular PSFQ protocol is to provide the guarantee in delay. They should provide delay guarantee for delivery to all that particular destination nodes. So in this protocol, the main principle of working is to slow and the fetch combination, slow pumping, slow. That means the data propagation is very slow in that particular network from source node to destination node, and the fetch is basically to offer enough time for hop by hop packet recovery. So it will provide enough time for packet recovery. So here we can see a multi-hop packet forwarding as well as recovering from errors. So in multi-hop packet forwarding, if we first look at that particular scenario, the packet are transmitted in a multi-hop communication. So basically, the packet, or simply we can call it a segment, all are same here. Packet or segment in same in wireless communication. So if you are talking about multi-hop packet forwarding scenario, let us assume in the first example, which is left side of this particular screen, there are four nodes, 1, 2, 3, and 4, and it is a multi-hop packet forwarding from node 1 uh, to towards 3 or 4. So let us say that this particular scenario where there is no link class and how that packet forwarding take place. The author assumes that there is no link class. All links are stable links. So without any obstacle, the packets will be transmitted from one node to another node. So the first, the packet or the segment 1 is sending from node 1 to node 2, then node 2 to node 3 to node 4. As the network is going to be maintained the stable links, so there is no obstacle. Smoothly the packet is transmitting from node 1 to node 4. The similar kind, node 2, the packet 2 as well as packet 3 will be transmitted. Here, he assumes that there is no link loss. So directly without any packet drop, all the packets are smoothly transmitted from node 1 to node 4. Let us assume that. We have another case. We can see from right side of this particular screen. So let us consider when we have some packet loss, let us assume that. Here, 3 packets we are transmitting. Packet 1 is transmitted successfully, packet 2 is lost, and packet 3 is transmitted successfully. In this case, we need to recover that particular packet which is lost in between the node. So in this particular example, we can see that packet 1 is sent to 2, then 2 to 3, 3 to 4. But in the case of packet 2, 1 is successfully sent, the packet 2 is lost here after receiving the packet 1 by the destination. So in this case, without the node 4, it doesn't receive any packet. Node 3 also, it doesn't receive any packet number 2, and node 2 also, it doesn't receive any packet number. As we are saying that there is no acknowledgement from the destination node to source node. So what it has to do, it will wait for some period of time. After that, it will send node 3. So node 3 is received, but according to the sequential count, it will check the missing packet. So the node 4 identifies that some packet was missed, then it will send the recover message, the control packet, to recover that particular packet number 2 towards that particular source. So everybody is going to send a recovery message for 2 towards that particular source node via again same intermediary nodes. So in this case also, this particular situation will leads to wastage of resources, because node 1 is the packet 1 is received, packet 2 is lost, packet 3 is received, but it will not accept packet 3. So again, once the packet 2 is transmitted, it has to transmit packet 3 also, again, which will leads to wastage of resources. So there are too many recovering messages has to be transmitted from destination node to source node. So further, what it is going to do is, as we can see in the previous classes, store and forward approach. Store and forward approach. That means once that any packet was dropped in the middle, what it has to do, the intermediary node itself, it will identify the packet loss, and it will not transmit the subsequent packet after that packet drop. So here we can see from this right side image, again four nodes are there. Packet 1 is transmitted successfully, packet 2 is dropped, but when it is transmitting packet 3, what it will do, instead of discarding, it will store. Okay, it will store that particular packet until the packet 2 is received. So what it will do, once the packet 3 was transmitted to the intermediate node called 2, what it will do, it will send the recovery control packet to node 1, so that the packet 2 will be retransmitted by the node 1. Once the packet 2 is received by node 2, it will retransmit packet 2 as well as packet 3 towards the destination node. So This is the advantage of this PSFQ protocol, so that the resources will be utilized in maximum manner. The similar kind of example we have, and the next protocol we have is rate controlled reliable transport. As we can see here, the image itself. Usually, in any sensor network, we have one sync node. We have one sync node and several cluster heads. But according to this paper, he proposed that based on the distance, he is going to maintain multiple sync nodes. So, this protocol that we are going to discuss is the rate controlled reliable transport protocol. Rate controlled reliable transport protocol, as the name suggesting that this protocol is reliably transport the sensor data, the whatever the data sensed by sensor nodes, from many sources to one or more sync nodes without any disturbances. That means that he assumes that there is no collision occurred, there is no contention occurred, there is no congestion occurred, because based on the distance he is going to be managed multiple sync nodes. So that particular node. But the drawback of this paper, as per my knowledge, the drawback of this paper is the node which is going to be sense the information, it has to sense to only one sync node, because according to this paper, this particular node is going to be sent to multiple syncs. It is sending the information to multiple syncs. So there is no fair allocation of the resources, and there is no efficient that much efficient of the performance. So in this particular protocol, what we are going to considering that not only one sync, we have multiple syncs are there, so that that particular node is going to be transmit broadcast the information to multiple syncs. So there may be a possibility of getting redundancy in this particular case. So how the working technology of this particular protocol? RC/RT, rate controlled reliable transport protocol. So in this protocol, few things that are controlled. That means the first thing that we have is a source node. We have a source node. Then we have a sync node. As you can see from this example, from this image, we have sync node, we have source node. So the source node usually basically reports the data towards the sync node at that particular rate. Let us assume that, as we can observe from this image, the data rate is R. The data rate is R. So, and according to this paper, he assumes that R should be a prime number. Assumes that R should be a prime number. And sync also sending the requests in the other direction towards that particular source node. The sync node particularly involved in this particular activity is called like congestion detection or rate adoption or the rate allocation, and also end-to-end the recovery of that particular loss. Though this, according to this paper again, the source node is also involved in the end-to-end loss recovery, just like congestion detection, rate adoption, rate allocation, which are generally controlled by the sync node. The end-to-end loss detection, loss recovery is done by both the sync as well as the source node. Right, as you can see from this slide, both are done by the source node. So each node in this particular protocol, it opens the contention towards the sync node first. It has to open the contention towards that particular sync node. Then the sync tells each node the rate that has to be used in this particular communication. So we are representing that rate with green line here. In this image, we are representing with green line. So the after telling the sync node at what rate the data is going to be transmitted. Once as we said now, R is a prime number here. So what happens is that the source node opening a connection to the sync node will tell the source node that is this is the rate you are going to use for sending the information. So each whatever how many source nodes are there, how many nodes which are initiating the transmission, each and every source node uh, sends that particular packet at that particular rate only. That is, the transmission rate is fixed. So this uh, at particular rate called R here. So R prime rate was once again informed by the sync node to that particular source node uh, to use at that particular rate only. That means it is sending two control packets. One is before establishing the path between before establishing the communication path between source node and sync node. At that time only it is broadcasting to all the neighboring nodes by stating you should use this particular transmission rate only. So all the nodes in that particular region are going to have the same transmission rate, so that he assumes that there is no collision or there is no contention and there is no loss was occurred because of this. So the sync detects that particular packet losses and initiates the loss recovery. The sync monitors congestion as well as reassigns sending rate to each and every node. So if any congestion is there, based on that congestion, either the flow rate may be increased or flow rate may be reduced. The source node follows what the sync tells to perform, what sync tells to do. So what the sync is telling, the same has to be followed by the source node as well as the intermediary nodes. So these are the some protocols we have. Still, there is a scope of doing research in this particular area. Still, there is a scope in energy harvesting routing wireless sensor network, mobility models. As we discussed, the node may be stationary node or the mobile node. So, in case of mobile node, uh, there is a still there is a scope in research of how the mobility of that particular link stability will influence the performance of the network. And then nanoscale communication. So very when we have micro sensor network technology, sensor itself very small, micro sensor in the sense again a tenth part of that ordinary sensor node. So in that case, we need to have nanoscale communication. There is a possibility of doing research in nanoscale communication. Body area networks. We can deploy the sensor nodes on body to check the status of the, especially in medical applications. But still, there are some complexities in establishing communication between the node to node communication is good. There is no problem there. But still there is a complexity in communicate establishing the communication path between the cluster head as well as the base station. Still the doctors are unable to find exact the readings from the body area sensor networks. And if we have integrated the sensors with web of things, there is a scope in research also. Bridging ad hoc sensor networks, deploying on-site web of things. This is also one very good research area. So RPL route stability in case of moving nodes and discontinuous interferences. Routing for video wireless sensor networks. And there are some links where most of the top universities are doing researches in wireless sensor networks, in especially in congestion control and flow control. You can see what is the current research is going on in that particular university by clicking on this link. There are 5 to 6 links are there. You can click on the link and you can check the current research. So this is about congestion control and flow control. And like the previous lectures, today now also I'll forward the papers on the congestion control and flow control for next presentation. Anyway, we have one presentation on Thursday, day after tomorrow. So after this, we are having another presentation